Hello, welcome to NFI online video tutorials. My name is Rajveer and today I'm going to teach you about SCADA. Alright, in this series of video we are going to see what is SCADA, what are its application, how to install SCADA in your computer, and how to design screens in SCADA software, and how to link that with your PLC to read and write the information. Okay, these are the typical things we are going to learn in this course. So this covers generally the basic aspects of SCADA. So starting with what is SCADA, I'm going to start this slide. SCADA stands for Supervisory Control and Data Acquisition. So if you see these keywords, starting with supervisory means which is at the top level. All right, control means we are controlling something, and data acquisition means you are acquiring the data, you are reading the information, right? So supervisory control and data acquisition itself means it's a software which is used to control the hardware, which could be your PLCs, PIDs, drives, servos, and which is also acquiring the data from these devices into a computer system. All right, this is the communication network. This is a SCADA system in which it is acquiring the data of these RTUs and also writing the values. So it's controlling and acquiring. It's both, combination of both. It's more like what you can say that HMI is something which a SCADA can do. All right, so let's move beyond, starting with SCADA architecture. In SCADA architecture we have a control center. Here you can see a computer system written SCADA here, connected by a main hub. Now this is an Ethernet port. Okay, so this is a PLC. PLC is connected by Ethernet board, and this is overall connected to a CPU. Okay, this has assigned some IP addresses which is read by this computer system. Now this PLC is connected to various field instruments. This could be your temperature scanner, or it could be any the sensors, and it could be sensors or actuators, various analog or digital. These are connected to your CPU, your PLC. Okay, and PLC is connected to your computer via main hub. So this PLC, this PC has a SCADA software inside which can interact with these field instruments via a PLC and this communication network. Okay, in this case it's Ethernet, and this computer is also connected to various other PLCs, unit 1, unit 2, unit 3. It could be multiple units, all right, based on this main hub. So this HMI, this is a human machine interface which is individually connected to the PLC. All right, so this is independently controlling and monitoring this PLC, but if you need a control station which can read the information from all the units, you need a SCADA system. Okay, so this is connected to all other units via a main hub. So this is the basic architecture of SCADA. Now let's see an example of the SCADA architect. Now you can see here we have a pump. All right, now this pump is having some of its own function. Now this is controlled by a PLC. All right, this is, you can say this is a tank, this is a level sensor which is giving information to another PLC, and this is a solenoid valve. So here we are controlling the level, okay, and here we are controlling the speed of the pump. So this is a kind of a process in which we are controlling the speed and we are controlling the level. So these independent PLCs are used for this sole purpose. Okay, now this PLC is connected, it could be by some Ethernet or Modbus, to a computer system which is having a SCADA software inside. So this PC can read what is happening in the field. So this is the field. Okay, that's the communication network. Okay, and this is the controlling and data acquiring center. And this icon, you can say this is a database in which you can also store the information about the speed of this pump from last, let's say, 30 days or 60 days or 1 year, and about the level. So you can read at any instant the level is being recorded in this database. That depends on how you are coding your PLC program and how you are maintaining the screens. So this is the database. So this can control and read the information and can store the information for longer term in this database. This is a basic architecture of SCADA. Now if we go deeper inside, in the field we have sensors, actuators, and controllers. Sensors, are the devices which senses the input physical quantity. Actuator is the one which controls that quantity, and the controller is which is in which you write the algorithm. So we have two types, digital and analog, in the field. Then we have communication, which could be wired or could be wireless. Then there's a supervisory control center in which we can store the database. So the information is linked in all these three areas. All right. To see what are the sensor and actuator could be. So sensors could be your pressure sensor, could be temperature sensor, proximity sensors, level sensors. Okay. These are the four typical sensors we have in the industry. Actuators could be valves, could be motors, or could be pumps. Okay. Controllers could be PLCs or PIDs. PIDs typically for dedicated temperature or level control. PLCs for step and analog control as well. Then the communication could be Modbus, Fieldbus, CAN, Profibus, and Ethernet, by which these field devices can interact with the control center. Control center you may find HMIs or PCs. So this HMI or PCs are controlling these field devices via communication network and also acquiring the data here. So this is the whole loop of SCADA. So the data can be acquired, you can display that, the information can be displayed, supervisory control is there. You can also add some alarm and tagging, okay, and data logging can be done. So it says a typical industrial control system is the one which is used to monitor and remotely control critical industrial processes. So there we need a SCADA system in which you have some critical processes which we need to control and monitor at a larger scale. Okay, so typical application of SCADA includes in food processing industry. Now if you can see here, this is a food conveyor lines, and this is a typical screen in which we can control the opening and closing of valve. You can control the temperature, you can control the flow, and you can control the level as well. Typical three processes we have which we can control: level, flow, and temperature. Okay, this is for the food industry. This is how you can make screen to depict what's happening in the field. This is a field and that's the control station. Another example is chemical industry. From outside you will see a big tanks, things like that. In the screen you can visualize the level, the temperature, and the flow of the liquid inside this tank in this SCADA screen. So you can see here closely, here it is written start, stop. You can start and stop the pump from here, and we have several set points. This is a GPM. This is the flow of what is happening inside the pump, and here you have a backwash filter pump. You can on and off. You can read the readings of this pump on the screen. So everything is happening online here, plant status, or what is happening actually in the field. So this is the control station. So you can monitor the data, and if you think that something is wrong, you can put it in the manual mode, or you can stop the pump. So this is the controlling. What these values are, this is the data acquired. Okay, so this is data acquisition, these values, and controlling. For controlling you have these buttons. So two things are happening all together. Another example could be water treatment plant, in which this is a typical layout of a water treatment plant in which you can see the liquid, the level of the liquid, the temperature, and the flow. All these are the three main areas you can see. So that was the three basic applications of SCADA, and if you have any doubt, give me a comment. In the next video we'll see how you can download a SCADA software for free. All right, let's see that in the next video. Thank you.